We're going to do trigonometric functions of any angle. And so far we have done problems only with acute angles less than 90 degrees. Now we're going to look at larger angles. And so far we've only dealt with the first quadrant. Now we're going to deal with second, third, and fourth quadrants to figure out our sine, cos, and tangent for various angles greater than 90 degrees.
In this diagram, we can see that x is equal to 3, y is equal to 4, and the angle from here to here can be worked out quite easily. So tan of theta is 4 over 3, so theta is 53.13 degrees. 53.13 degrees is an acute angle because it is less than 90 degrees. However, as you can see here, our theta goes all the way around, which is 360 degrees, plus 53.13 degrees. Our actual angle theta is 466.26 degrees because we've gone through one complete revolution plus 53.13 degrees.
Now when we take a look here, this triangle is a 3, 4, and the radius is 5. So this is a 3, 4, 5 triangle that's right angled. And it has a degree of 53.13 degrees in here. Now if we take a look at the sine of that, it's 0.8. If we look at the cos of that, it's 0.6. If we look at the tan of that, it's 1.33. And why? Because x, y, and the radius are all positive units. Therefore, all the sine, cos, tan, secant, cosecant, and cotangent are all going to be positive in this quadrant, which is to the upper right here. Now, if we add 360, we get this number here. And if we take a look at the sine of that, that's 0.8. If we look at the cos of that, that's 0.6. And if we look at the tan of that, it's 1.33. So no matter how many times we go around and end up with 53.3 from the x-axis here, we're going to get the same sine, cos, and tan. Now in quadrant 1 here, we had a 3, 4, 5 triangle here where sine, cos, and tan were all positive. Now let's do a 3, 4 triangle, but in quadrant 2 here, where x is minus 3, y is plus 4, and the hypotenuse is 5. If we do that, then our degree 53.1 degrees is what we have in here. And if we look at the sine of that angle is going to be 4 over 5, which is 0.8. If we look at the cos of that, that's minus 3 over 5, which is minus 0.6. If we take a look at the tan of this angle here, it's going to be 4 over minus 3, which is minus 1.3 repeated. But this is not the angle that we're trying to find here. The angle we're trying to find is 180 minus this angle to give us this angle here, theta. So if we subtract from this 180, this is the actual degree that we have here for theta from here to here. Now let's take a look and see what the sine of that is. The sine of that angle is 0.8, same as before. The cosine of this angle is minus 0.6, same as here. And the tan of this angle is minus 1.33, as we worked on before. So this angle here, when we move it over here and make an acute angle triangle, the ratios that we have of x over y, and so forth, will work out exactly the same. So this angle here that we've got, 126.87, here will have the same sine, cos, and tan as this angle here as an acute triangle. But notice everything up in our quadrant 1 here was positive, but the only thing that's positive in this quadrant happens to be our sine. Everything else is negative. If we move our 3, 4, 5 triangle into quadrant 3 here, we'll find this is minus 3, minus 4, and the hypotenuse is 5. If we do the math on here, if this angle here, the sine of this angle is minus 4 over 5, which is minus 0.8. The cos is minus 3 over 5, which is minus 0.6. And the tan is minus 4 over 3, which is positive 1.3 repeated. So out of all these sine, cos, and tan, only the tan is positive. The other ones are negative in quadrant 3. Now notice this angle is the one that we want here, which is 180 plus this angle that we've got here. So let's add to this 180. Sine of this is minus 0.8 as we've had here. Cos of this is minus 0.6 as we have here. And tan of this is positive 1.33, which is what we have here. Now if we move our 3, 4, 5 triangle into quadrant 4 here, we're going to find the sine of this angle, which is again 53.13 in here, is going to be minus 4 over 5, which is minus 0.8. Our cosine of that angle is adjacent, which is 3 over 5, which is positive 0.6. Our tan of this angle is minus 4 over 3, which is minus 1.3 repeated. Now the angle that we've got all the way from here to here is going to be 360 degrees minus this angle will give us the total angle here. So let's do a change sign on this, and let's add 360, and let's put that into memory. And this is the angle that we've got all the way around from here to here. So let's validate that these work. So sine is minus 0.8, cosine is 0.6 positive, and tan is minus 1.3. So the only thing that is positive in this quadrant is the cosine. We have what's called the CAST rule, C-A-S-T, because in quadrant 4 only the cosine and equivalent secant are positive. In quadrant 1 all are positive. In quadrant 2 only the sine and cosecant are positive, and in quadrant 3 only the tan is positive. So cos, all, sine, and tan are positive only in these quadrants. Let's take a look at this problem. A point on the hypotenuse of a triangle has coordinates minus 3 and minus 5. So if we draw our x and y grid here, minus 3 is 1, 2, 3 units this way and 5 units down this way. So this is the hypotenuse of our triangle here. Now the angle for that will be this one here, and we'll call it beta for now. Now it says what quadrant is it in? So this is quadrant 1, 2, this is quadrant 3, so it is in quadrant 3. Now we're given that the opposite is minus 5 and the adjacent is minus 3, so the tan is minus 5 over minus 3, which is 1.6 repeated. So this angle here is 59.03 degrees. However, what we want to find out is what is the angle theta, which is all the way around to here, which will be 180 plus the 59.03 degrees, and that works out to be a total of 239 degrees. Now if we put in 239 degrees here, and we take a look at the sine is minus 857. If we look at the cos, it's minus 0.514. The tan is positive 1.6 repeated. The cosecant is 1 over the sine, so that's minus 1.166. The secant is 1 over the cos, so that's minus 1.944. And the cotangent is 1 over the tangent, which is 0.6, which is positive. So we can see here the tangent and the cotangent are the only things that are positive here. This is cosine, all, sine, tangent. If we're given a degree, such as 125 degrees here, we know it's in our second quadrant. And we use the hypotenuse of that 125 degrees to form a reference angle here of 55. And we do that by drawing a perpendicular down to the x-axis at a right angle. So the sine of 55, which is this over hypotenuse, will be the same as the sine of 125. So once we figure all this stuff out, we can subtract the 55 from 180 and get the 125. However, what happens if we're given this information without any context of which one of these quadrants it's in? For instance, if the sine is positive 0.8192, the cos is negative 0.574, and the tan is negative 1.428, how do we know where this angle is? Because it could be in any one of these four quadrants. Well, first of all, the sine is positive, which means it has to be either in quadrant 1 or quadrant 2. The cosine is negative, so it can't be here, and it can't be here. The tangent is negative, and tangent is positive here, so it has to be in the second quadrant. So let's put in a number here, 0.8192, and do the inverse sine, and we find that it is 55 degrees, but we know that 55 degrees is in the second quadrant, so we're going to change sign here and basically subtract that from 180 degrees, and we find that the angle that we're looking for again is 125 degrees here. If we're given an angle of 236 degrees, the way we can find out our reference angle is to take 236 minus 180, and that will give us our reference angle of 56 degrees. And again, the reference angle is when you take the hypotenuse of our angle, which is 236 degrees, and drop a perpendicular down to the x-axis. But again, what would happen if we're given these values for sine, cos, and tan, and asked to find what is the actual angle? Well, if we look here, the sine is negative, so it can't be here or here. It can't be in either of these two quadrants. Now the cos is negative, so the cos is positive here and here, so it can't be here, so it has to be in this quadrant here. So if we want to figure that out, let's put in 0.829, change sign, do an inverse sine, and we find that this is minus 55.99 or 55.99 degrees, or basically 56 as a negative. But because it's 56, we know it's in this quadrant. This is 56 here, so to figure out our angle, 180 degrees plus 56, and we get indeed that our angle is 236 degrees again. So we have to eliminate which one of these quadrants that it's not in to find the quadrant that it's in, and then work back from there as to what the actual angle is. Let's take a look at example 13 out of the book. It says if sine theta is 0.6293, find two positive values of theta less than 360 degrees. Now if we remember a cast rule, the cosine is positive here, sine, cos, and tan are positive here, sine is positive here, tan is positive here, everywhere else they're negative. That means it's going to be in quadrant 1 or quadrant 2 for this sine. So let's put in the value, 0.6293, and let's take the inverse sine of that. What we get is 38.998, and it says work to the nearest tenth of a degree, so that's going to be 39 degrees. So 39 degrees here, where we form a right angle triangle down to the x-axis here, and we also have 39 degrees here where we drop a perpendicular down to the x-axis here. 39 is one of our two angles. The other angle we're going to get by subtracting this from 180 degrees. So let's subtract this from 180 degrees by changing sign here and adding 180. So our other angle that we've got here is 141 degrees. So this is 141 is one of our two angles, 39 is the other of our two angles here. Now take a look at example 14. It says find to the nearest tenth of a degree two positive angles less than 360 degrees that have a negative tangent. Now if we take a look here, this will not have a negative tangent because all are positive. This won't have a negative tangent because this is where the tangent is positive, so it has to be in one of these two quadrants. Now we're given the tangent is minus 2.25, so let's put in 2.25, change sign. Let's do the inverse tan, and we get 66 degrees. So 66 degrees is what we have. We drop a line down here perpendicular to the x-axis. This is 66 degrees here. And we're also going to find that it's in also this quadrant here. Again, we drop down a perpendicular here, and we find that these are the two angles of 66 degrees. To find this angle, we're going to have to take 180 minus 66. So we already have minus 66, so let's add plus 180. And we get our first angle is to the nearest tenth of a degree, 114 degrees to here. Now the other one is 360 minus 66. So let's put in 360 minus 66, and that gives us 294 degrees as the other positive angle that we've got here. And now let's take a look at example 16. It says find two positive angles less than 360 that have a negative secant of minus 4.22. Now if you remember, secant is 1 over the cos, so it can't be here because these are positive, so it has to be in one of these two quadrants, which is quadrant 2 or quadrant 3. Let's put in 4.22. Let's do a change sign. And let's do a 1 over because that's seeking to get cosine. We'll do inverse cosine now, and we get 103.7. So this angle here is 103.7, so we found one of our two angles. But as we saw, we have to drop a perpendicular down here to the x-axis to find the reference angle, which is this one here. And to find that, we're going to have 180 minus the 103.7. So let's do a change sign here and add 180. So our reference angle really is 76.3 degrees. So we know that 76.3 is here, and the other angle that we want is 76.3 here. So to find that, what we're going to have to do is we're going to have to add 180 plus 76.3. So let's just add 180, and we get our other angle, which is 256.3, as we can see here. 256.3 degrees. So those are our two angles that we have that has a negative secant.